Here is a general view of the bridge from the roadway, looking north from the downtown or Fort Duquesne Boulevard end of the bridge. The contractor is substantially complete with construction at this point, but you can see at this approach span, span 1, they still have to do work on the sidewalk in the approach spans, and also with some of the expansion joints. The bridge is over 600 feet long, and it actually expands 4 inches from the fixed bearing at the second pier over toward the first pier. Now, this is at the near approach. In bridges we say near and far, but it depends on the direction of the compass, but this is in span 1, and we are approaching a block out for concrete that will secure the strip steel joint. The strip steel assembly includes galvanized steel angles and studs to help lock it into place into the concrete. The joint was fabricated by the D.S. Brown Company, who is located over in North Baltimore, Ohio. You also see our nice masonry towers that date back to the 1920s, with a new obelisk that we put on and a 2-headed lantern system that recreated the vintage look from the 1920s. Now this is another look at the reinforcing steel in the concrete blockout that will hold the strip seals. There's a maze of rebar, studs, and forms that secure this strip seal in place. The strip seal is made of angles, we call it armor, with a neoprene compression seal inside. It gives movement and flexibility to the bridge for expansion. And the idea is to make it very smooth when you ride over it upon completion. So we don't like any rattling, and it's important to have a very solid, secure system once the assembly is in place. This photo shows the armor for the compression seal, strip seal, on the left side of the photo. You can see the galvanized steel angles, the neoprene rubber joint itself, which is wedged in there, and these steel studs that stick out perpendicular. Those studs help fasten the joint into the concrete. Now looking ahead at span 2, this is the anchor span. You can see the steel towers ahead and the sidewalk, the steel suspension chain made up of I-bar plates, 2 towers, and the portal frame that gives stability to the whole structure. You also see underneath the sidewalk brackets, there's a conduit bank that carries gas lines and electric lines. Here you can see the new curb plates. Because the old curb plates were flat, they tended to pond water and retain salt accumulation from winter maintenance activities. They would tend to be significant corrosion in the plates, which would allow more corrosion to adversely affect the bottom flanges of the stiffening girders. These have been a constant maintenance item over the years, but hopefully these new plates, which are sloped to induce positive drainage, will mitigate that concern. We also have steel bolts in the vertical position that will act as handles to help remove these plates during the inspection process. We would inspect these plates every 2 years. This is one of the suspenders that carry the load from the roadway deck, the dead load of the concrete deck, the steel structure, and live load from truck and traffic, up to the suspension chain. This is in pure tension. That's a 4-inch wide bar. There's a pair of them. It carries a lot of tension. This view shows some of the primer paint that went into the paint system as we sandblasted the old paint off, repaired some elements, replaced some of those old rivets, which we don't do anymore, with new button-head steel bolts. And you can see there's a lot of sharp edges on these plates and structural members. The beauty of the bridge is in these unique shapes, but also it's a problem because paint has a trouble adhering to these sharp edges. You tend to get some rust bleeding, and we try to seal these little joints and crevices as best we can, and then have a good 3-coat paint system on top of that to preserve the life of the structure. Here's a close-up of the top flange of the stiffening girder. You see the different plies of steel, the old rivets, some corrosion that has happened over the years that tend to pop the plates off of each other. As I said before, it's very hard to keep this in a state of good repair because of the sharp corners and edges on the plates, and you get incipient corrosion. This is a sidewalk handrail being put back in place. The contractor had to remove these elements because the entire sidewalk, the concrete portion of it, and the steel bracket system underneath had to be replaced. These were taken off-site, cleaned and painted, and put back in their former position. Notice the contractor is harnessed off so he doesn't fall. And having good traction on your shoes, hard hats, and harnessing system is paramount on these major construction projects. This is at mid-span, or the low sag point of the bridge, looking downstream. You can see the I-bar chain system, the short hangers, and the top of the stiffening girders. There's an assembly of 17 plates at each joint where those I-bars come together. And this is a look up to the top of the chain where you see the portal frame. The load from the suspension chain travels up to the top of the towers, and then it's carried in vertical compression by the towers down to the piers in the river. This is the area of the approach slab located at the far or north end of the bridge. Approach slabs are reinforced concrete pavement elements, stiff elements, which are commonly used to provide a continuous, smooth transition from the approach roadway to the bridge itself. If you don't use them, you might end up with an undesirable bump at the bridge. This is the last span on the bridge, span 5, where the contractor is placing rebar. After the rebar and forms are in place, the contractor will pour concrete for the sidewalk and bridge parapets. They put a nest of top and bottom rows of reinforcement at perpendicular angles, and they tie the joints together. This is Jake Fatullo. Jake was our escort during filming and happens to be a graduate of the Swanson School of Engineering. I believe he graduated in 2014. He was employed by one of the engineering firms we use for construction management and inspection, and he wanted to say hi to everybody. This is the last thing we wanted to show today. This is over at the Roberto Clemente 6th Street Bridge. Note the very poor condition of the roadway curb plates. As I said earlier, the curb plates are a problematic feature of the bridges. You can see the effect of corrosion over the years. Starting late next year, the 6th Street Bridge will undergo a 2-year rehabilitation project with a complete closure like the other 2 sister bridges. The 6th Street Bridge carries the most traffic of the 3 and has a number of key stakeholders, such as the Pirates and the Steelers during game days. The bridge also has a pair of bike lanes and a kayak facility on the riverfront trail. So we do expect to have a lot of communication and coordination with these stakeholders as we complete the design plans.